Today, we're going to talk about Windows workloads on AWS. I'm Scott Zimmerman. I'm a solutions architect who's been with AWS for a couple of years. Before that, I was with Microsoft for several years. And I thought, in the spirit of Microsoft and AWS working together, I assume that many of you have been to many Microsoft conferences over the years, and you know how they like to label the sessions as level 100, 200, 300. Well, I'll tell you, this is probably mostly a level 200 talk. Some of the slides you're going to say, well, that's a 100, Scott. A couple of the slides are maybe a 300. But let's go ahead and get started. So this is our agenda today. I'm going to talk about why customers are running Windows on AWS, because that's a common question. And then we're going to talk about what Windows workloads run on AWS. And then where to get started, and some of the enhancements that we have, and how to do it. Okay, sound good? We'll take questions at the end. And you can either come up to the microphone to ask your question, or the way I like to do it is, because we got to make sure everybody hears it, if you ask a question, I will summarize it and make a synopsis so that I can tell you, confirm to you what question I'm answering, and everybody else can hear it too. All right, so why are customers running Windows on AWS? I get asked this a lot. Some of the key reasons that customers are doing this is performance and reliability and security, flexibility and agility, and the ability to scale up and down instantly. And I will talk about each of these more often as we go through the talk today. Now here's a customer success story that I'd like to start with. I'll give you a couple of case studies. We have many case studies on our website, just a couple that I want to touch on for you. Dole migrated their entire SharePoint enterprise platform to AWS with a cost savings of $350,000 in the first year, which is pretty substantial. Not only that, but this enabled them to really rapidly deploy new websites across the enterprise. And there's a quote by their director of IT. Forgot the animation on that slide, so I'll go ahead and build that out as I tell you this story about Hess. This is really interesting. Hess decided to sell several of its businesses so that it could focus on its energy exploration and production. And so in anticipating that they were going to be selling off several of their businesses to potential buyers, they wanted to make that an easy transition. So Hess IT initiated a contractual agreement to build all of their IT systems onto AWS within 6 months, which was a pretty aggressive goal. This actually worked. But the amazing thing about this story is that when they sold their businesses, they were then literally able to just hand over the keys. Here's the IT property, it's yours. So that's how important it was to be able to insulate and encapsulate all of their IT operations into AWS. Now, if you ask, okay, why would people want to run Windows on AWS? The short answer is that we've shown over and over again that we are committed to customer success. Customers are running Windows workloads on AWS for several important reasons. I touched on them. And here's a short list. The security and reliability is very important. We have 99.95 SLAs available in each of our regions. We offer performance and experience. There is no compression algorithm for experience. We've been in the cloud now for 10 years. We also have the ability to scale up, but also down. Instantly scaling down a test or a demo SharePoint environment, who can do that? That's not easy. Typically, it takes months to build out a SharePoint environment, when you include the acquisition and requisition of the servers and the racking and stacking and so forth. Well, with our CloudFormation service, you can not only deploy SharePoint in a matter of minutes, or certainly within hours, you can also immediately turn it off as soon as your demo or your experiment or your beta test is over. We also have a super strong partner ecosystem, especially around Windows. You'll find that many partners that we have deep experience with running Windows workloads. When they formerly did it on-premise, now they're doing it in the cloud with AWS. Now, your applications and data are protected by our highly secure facilities and infrastructure, as well as an extensive network and security monitoring systems. These are some of the logos that you see of the certifications and compliances that we've achieved, and there are many others listed on our website with details. Many of our certifications are sort of these bullets are touching on the security in layers approach that we take. What the security in layers approach is about is that AWS is responsible for securing the security of the cloud, and you're responsible for the security in the cloud, the applications that you deploy, et cetera. So just touching on a couple of these things, we provide secure API access. All of our services, all of the AWS web services have APIs that have HTTPS endpoints, so you're always going through making a secure call. And as far as compliance goes, all of these API calls are being logged and tracked with our CloudTrail service so everything in your account is being monitored for you to audit. In terms of reliability, you can rapidly and predictably commission your entire infrastructure farms with our CloudFormation service or with our APIs. The EC2 service level agreement, as I mentioned, is 99.95 availability for each region. So that's the reliability that you're looking for. With our auto-scaling service and our elastic load balancing service, you'll find that these marry together really well, especially for web applications with IIS and ASP.NET. So here's the beauty of this. You have the elastic load balancer in front of a web farm of front-end web servers, and those are in an auto-scaling group. So those can expand and contract as needed almost instantly. But the elastic load balancer can automatically pick those up and say, well, this server has not responded for a moment, so I'm taking that out of the rotation. For some reason, that server may have died. But now the traffic is picking up based on CPU load or network metrics that you put in or time of day schedule. You can say, at this time of day, I want to add 10 more servers to the front-end web servers. And those are automatically added into the elastic load balancer for round-robin or weighted round-robin traffic balancing. Now, in terms of high performance, we have, as Matt Woods mentioned in the previous talk, we have over 30 instance types, a very large family of instance types, so you can optimize for CPU or network or memory. As you choose your instance types, you want to base them on the type of workload that you have. For example, for SQL Server, you would choose our large amount of memory instance types. Also with AWS Direct Connect, which was mentioned in the previous talk, you can literally make your AWS resources and your AWS data center, your virtual private cloud in AWS, look exactly like an extension of your data center. So let's say today that your data center is full and you've been given a new project to build out a sister data center or a sister environment for it, and you're thinking about, okay, how am I going to route the traffic between them and how am I going to set up the infrastructure for low latency? I need some of these applications may be having a need for synchronous transmission times with low latency. All of that can be done with the Direct Connect service between your on-premise facility and your AWS resources. So now you have the ability to rapidly deploy a new Windows environment for Windows workloads in AWS and have it look just like the traffic that's overflowing from your current data center. So that's really powerful. And I'll show you a couple of diagrams about that as we go. Now, this slide is showing our global infrastructure today, serving over 1 million active customers in 190 countries. The Amazon CloudFront service and the Route 53 service are offered from over 50 different edge locations around the world. What we say in terms of the Elastic Compute Cloud, our EC2 service, as it's called, is that we have today 12 regions and 5 new ones coming online this year. So those are in each of those regions has what we call at least 2 availability zones. So let's talk a little bit more about availability zones. One region, the US East, has 5 AZs. All regions have at least 2, and some have 3 or 4. A region is a physical location in the world where we have multiple AZs, or availability zones. Each AZ consists of one or more, more than one discrete data center with redundant power and networking and connectivity. And these are close enough, like tens of miles geographically, to allow for very low latency. Think on the order of 1 or 2 milliseconds typically. So you can do synchronous architecture, synchronous design data replication. However, they are distinct floodplains and electricity grids, et cetera, and network backbone, so that you have high availability. The importance of this is, I can't overemphasize this. Whenever you talk to an AWS solutions architect or one of our system integrator partners, you will find us talking to you about use at least 2 AZs in your architecture. The reason is that you want to be protected in case there is a complete disaster at an AWS facility with one AZ. You want your application to be able to still run. Now, this is incredibly hard to do on-premise or, to my awareness, with other cloud vendors. AWS makes it easy. In an on-premise world, we typically talked about, well, things like SQL Server always on. People set that up and they think that they're getting highly available SQL clusters. But you know, that's true if a server fails. When you go with SQL Server always on, you've got that capability to fail over from one server to the other. But what about the entire facility going down? That's very hard and costly to achieve that. But with AWS availability zones, that's much easier. Okay, so what workloads can I run on AWS? Literally all workloads. Any Windows application runs on AWS. And we have customers to back that up. I'll talk to you a little bit more about that as we go. Let's see, I'm getting ahead of the slides here. I want this slide with the notes on this slide. Thank you. Now that we've talked about infrastructure, let's talk. Can you just go forward on this? Thank you very much. All right. This slide shows all the areas where we can help customers. You can get started with a project anywhere in your organization. And so this shows the different areas or topics. For Microsoft Shops, think of this slide as like your AWS decoder ring, if you will. The types of Windows workloads you can run on AWS include information security, such as integrating with Active Directory. And by the way, we provide several options and services for integrating with Active Directory, including managed services. You can also run business apps, such as HR and CRM. You can also run corporate apps, such as SharePoint and Exchange Server. And of course, end-user computing and DevOps and infrastructure. I really want to talk more about DevOps as we go along, because in my experience, AWS, what we're doing with DevOps, especially for Windows workloads, is really phenomenal. We have a service called Elastic Beanstalk that was mentioned in the previous talk. This is really simple to deploy ASP.NET applications. It's ideal for web apps with IIS. We also have Code Deploy and CloudFormation, which I touched on a second ago. Okay, now what are corporate apps in AWS? We have customers who have told us that they improved their availability by moving to AWS. Now think about why that is. Again, it's really hard and costly to build an application that runs in 2 data centers to improve your availability. It's not that hard to build redundant storage arrays and SQL Server always on, but to put that in 2 data centers is costly. We also support bring your own license, which is really important for Microsoft Shops that may already have SharePoint, Exchange, SQL Server, and Windows Server licenses. We provide you the flexibility to do that, and I'll mention that a little bit more shortly. So what I'm showing here is a reference architecture of how you could deploy SharePoint on AWS. Now this diagram might look a little busy at first. I hope you can see that. What I'm going to talk about are the icons in here. I'll go through this sort of block by block. At the left-hand side, your left, you see the internet gateway. Traffic is coming into the web, and what we have in that layer, you see elastic load balancing in the public subnets there. So the traffic comes through the internet gateway, goes to the load balancer, and that spreads the traffic out to your front-end web server, your SharePoint front-end web servers. Then we have in a private subnet, which are these longer horizontal yellow blocks. You see the private subnets there. By the way, the first row and the second row are identical. Those are just 2 different AZs, but you deploy them for redundancy in 2 AZs, as I've mentioned. So in the private subnet, you see the front-end web application servers, the distributed cache, which is a new server in SharePoint 2016, and you also see SQL Server always-on group there. And in the third AZ, which is available in some regions, I'm showing you the file share quorum there, where you can get truly high availability by putting that file share in a third AZ. Now, what that means is that if any one of these availability zones suffered a catastrophic loss, such as a major flood or earthquake event, your SQL Server always-on group would continue to be functional. In some cases, I have to admit, we do not have 3 AZs, so in that case, you may want to run the file share quorum on-premise and use direct connect between your data center and AWS, or you may want to run it in another AWS region. All right, let's go on. Now, in this slide, we're showing a diagram of a typical web application that is very popular with ASP.NET. And what we have at the top is our icon for the Elastic Load Balancer. So that's showing you that we're spreading traffic across 3 instances. The gold blocks in all of our diagrams are EC2 instances. EC2, again, is our Elastic Compute Cloud. So those are web servers. Below that, you see 2 blue databases. There's a master and a slave in Amazon RDS. So when you run SQL Server in Amazon RDS, which is our managed database service, you are automatically getting a master and a slave available to you. And we put those in 2 different AZs for high availability purposes. You can run .NET applications in EC2, as it's showing here. Those might be ASP.NET applications. You can also use CloudFormation templates to automatically provision this entire infrastructure. So with CloudFormation, again, I just want to tell you how powerful this is and how convenient it is. What you do is you build a script, essentially. It's a JSON data file, so it's really just data. But you build a script of what you would like your environment to look like. You click a button and deploy it. When you're done with your test or your dev environment or your demo, you click a button to shut it all down. So you're not paying for anything past that point. That's really powerful. But for production, it's also useful because you're going into production with the exact same environment that you have repeatedly tested over and over. So it's very reliable and highly repeatable. So that gets into continuous integration, and we're going to talk a little bit about that. For those of you who may think, you're a Microsoft shop and you say, okay, AWS sounds a little bit new to me. How do I learn how to use this when I'm really familiar with Microsoft Dev Tools? Well, we are also a huge Microsoft shop. We work very closely with Microsoft on all of the Amazon machine images that we build for Windows Server. And we support Visual Studio and PowerShell and System Center and SQL Server. So we're very much a Microsoft shop. And I love Visual Studio myself. I have a developer background. We have a .NET software development kit that allows you to write C# code to call all of the AWS APIs. So all of the services that are available in AWS that have APIs, you can write code to fully automate that with C#. And the toolkit that plugs into Visual Studio is really slick. You can, without ever leaving Visual Studio, you can navigate around your AWS resources and launch them and terminate them and check on the status of your simple queuing service. Maybe your application is sending messages through a queue or a simple notification service. You can see those showing up in your queues in your account as you're testing your application. And you can pause, set a breakpoint in the debugger, and look at the status of where that message is in the queue, and then allow your other application to pull that message off and see that it got deleted from the queue, etc. So being able to use our toolkit to actually debug your code in the cloud is really powerful. Okay, so we talked about the infrastructure, and we talked about the types of workloads that you can run in AWS. So where can you get started? First of all, I want to say again, security is job number 1. It's the first thing that we think about with everything we do. Now, this slide is a little bit busier. I'm going to pause here for a moment for everyone to have a chance to catch up on this. Can you take the note slide back one, please? Okay. Forward one, please. Thank you. Now, it can be difficult to see a latent security threat in traditional architectures because of the high degree of interconnected systems, right? So one thing you want to think about when you move to the cloud and cloudy architecture is you want to think about loose coupling. That's very important. And that our simple queuing service and our simple notification service are a major architectural building blocks that you want to think about as you do that. But by moving to AWS, you automatically get to take advantage of what we call our shared responsibility model. As I mentioned before, we're responsible for the security of the cloud, and you're responsible for the security in the cloud. Now, under this model, you will benefit from a number of things, like the purpose-built hardware that we've designed to work together and provide an extremely small attack surface. You're going to get our ongoing investment in security tools and features. So I would hazard a guess that we have more data scientists and security experts and PhDs working on just focused on security than what many of our customers are able to provide on staff for themselves. So take advantage of that. Leverage our abilities. The ability to build a resilient environment without the capital outlay. That's a key advantage because you can focus your capital resources on building your best-of-breed application rather than working on these lower-level infrastructure pieces. Our global security team is constantly monitoring security issues for over 1 million customers. Now, if there is some sort of an issue, we will fix that issue, but it's immediately fixed for all of our customers. So everybody will benefit from that. When we fix it for one, it's fixed for all. The US military, global banks, and healthcare organizations, and other extremely security-conscious customers are all running on AWS and relying on us. Okay, so to protect your application, AWS invests in a broad portfolio of security and identity and management tools to ensure that your application will be safe and reliable and compliant. In many cases, government organizations have compliancy requirements. Now, here are some of the services that touch on these key security topics. First of all, I want to mention again our virtual private cloud service. What it does is it allows you to encapsulate your network infrastructure inside of AWS in your own set of subnets and route tables. And for example, you could say that you do not want internet access into your virtual private cloud. You can provide a direct connect service, a gateway back to a virtual private gateway back to your on-premise network without even having an internet gateway into your virtual private cloud in AWS. So that means that all traffic inside of your AWS environment that you want to get to the internet, it has to go back through your corporate network just as if it was sitting in your own data center. That's how it would work. And out through your perhaps multiple levels of firewalls and your intrusion detection system and your bastion host and your NAT and so forth to get out. So again, you can do that without any internet access into your AWS resources. For encryption, we provide 2 services for key management. For identity, we provide several options for Active Directory, and you can even bring your own identity system, and we support SAML 2.0 with our identity and access management service. And we're big on compliance. CloudTrail, our AWS CloudTrail service allows you to track every single operation that happens in your AWS account for auditing. Okay, so here's more about virtual private cloud. This lets you provision a logically isolated section of the AWS cloud where you can launch your AWS resources on a virtual network that you define. So you're going to set up the IP addresses, the subnets, the route tables, etc. Route tables are really simple. I'm a software developer. I didn't have a lot of networking background before I came to AWS. I'd built a few small ones, but I had dealt with subnet, bitmasks, and so forth. Well, when you look at a route table in AWS, you'll find out that they're extremely easy to set up. And it's actually not an uncommon thing now with DevOps being the way it is, that software developers and infrastructure teams are working closely together. So all of this really comes together in building and deploying network applications in the cloud that are loosely coupled. Again, you can have a virtual private network connection between your on-premise environment and your virtual private cloud. We have a firewall built in called security groups. It's a firewall that is very simple to set up. But in addition to that, you can also set up network access control lists on all of your, to all of your subnets. Now here's a diagram that shows what a virtual private cloud looks like. So you see the VPC icon in the upper left corner. That's our virtual private cloud service. You see two options here for traffic to get in and out. At the top, there's an internet gateway that's routing traffic out to the internet. So you may provide that if, for example, you're running an IIS web application and you want to have customers being able to view your public-facing website. All of the gold padlock icons there are showing subnets. And inside of those subnets, you see orange blocks, which are your EC2 instances. Each of those EC2 instances has an IP address, perhaps a public-facing IP address if it's in a public subnet. If it's not a public subnet, it's a private IP address. All of those there you see are 10.0s, so those are private IP addresses. Now, you can also have, at the bottom it shows, a virtual private gateway. Like I mentioned, that can be a VPN connection or our Direct Connect service. So from your on-premise network, you can connect in with the virtual private gateway, and you could have either or both of those. Either an internet gateway or a VPG, or you might just want a VPG without an internet gateway. Notice that the virtual private cloud is spanning the two availability zones. So that's important. I can define, again, that I want to put SQL Server and IIS in two different availability zones for high availability purposes. And I can put all of that into my VPC inside of AWS. All right, so let's talk about more of the tools that you use and how you approach this. We have a comprehensive set of tools. And if you're familiar with the Microsoft development environment, you're going to find that you're pretty familiar already with how to do this in AWS. I'd like to emphasize DevOps and our CloudFormation service. CloudFormation, again, allows you to script a picture of what you want your environment to look like. We have a tool called CloudFormation Designer, so you can literally draw the picture. We also have a tool called CloudFormer, so if you've got an environment that's working the way you want it to after you've set it up manually, you can build the script from that, just say take a snapshot picture of that. But the result is that you get a JSON template. A file, a JSON data file. You can manually write that yourself, or you could have someone give you a working sample, such as you can download one from AWS. We have many sample JSON templates, especially for Windows workloads. Go on our website and look up our quick starts, as they're called, and you'll see that our quick starts provide you with a detailed implementation guide and CloudFormation templates to get you up and running for things like Remote Desktop Gateway with Microsoft, Active Directory, SQL Server Always On, and SharePoint and Exchange. Another neat thing that we provide, it's really powerful for Windows environments, is EC2 run command. It allows you to automate repetitive tasks across a large fleet of machines. Some of the things that you can do with EC2 run command are join servers to an Active Directory domain, bootstrap your applications, deploy configuration management solutions, and you can easily run PowerShell commands across multiple servers. Now, there is a remote PowerShell capability with WinRM built into Windows Server, but you have to open firewall ports for that, and it doesn't run those commands on every server as easily. So this feature is really well built for Windows fleets. All right, let's talk about licensing. We've got three columns up here. The first column is where you buy your licenses from AWS. That column applies only to Windows Server and SQL Server. AWS is the largest reseller in the world for those applications, Windows Server and SQL Server, but we do not sell other Microsoft software products with our EC2 instances. In this case, AWS manages the licensing, and you have pay-as-you-go pricing, and you have unlimited cows. You don't have to worry about the cows. There's no need for software assurance. Now, in column 2, you see the option to bring your own license. This is really important for organizations with SharePoint and SQL Server. If you're deploying SQL Server, the license cost itself is probably a larger part of your total cost than the EC2 infrastructure that you need and the storage. Now here, you don't need to pay for software assurance because we offer dedicated hosts. Dedicated hosts are a feature that we have where you can run on you own the virtual machine hardware that is dedicated to your use. As long as that's in your, commissioned in your account, you are on that box. That allows you to take advantage of bringing your own license. That complies with the Microsoft licensing terms, for example, and other third-party ISVs. So in column 3, you have the license mobility option. Now this works in a multi-tenant environment. You're running on servers that are, your instance is your own, but you're still running on a shared tenancy environment. In that case, you do need software assurance to be able to bring your Microsoft license into the cloud. And you can do that with SharePoint, SQL Server, etc. So here's how dedicated hosts look. A dedicated host supports bring your own license because you can see the number of sockets and the cores that are installed on that host. And you can then deploy your instances inside of that host. Each instance is a subset of the whole dedicated host itself. As long as the dedicated host is active in your account, that means your applications are running on that same box. And that complies, again, that complies with the licensing terms that is required by Microsoft or other ISVs. We have placement features like host targeting and instance affinity, so that you can, this provides you with full control over how your licenses are used in EC2. And it's really easy to get started in AWS. Let me show you an example. On this screen, you see our AWS Management Console, where the first step in the wizard, step 1, you choose the Amazon machine image that you would like to launch. And you'll see here that we have several Linux options. And, well, this screenshot is just showing you the Windows Server options. But this is so easy that you can do it in a matter of minutes. Even Phil, our marketing guy, has done it. You choose the Amazon machine image you want. Like, for example, Windows Server 2012 R2 base. When you see the word base there, that means without SQL Server added on. You can also choose Amazon machine images that already have SQL Server pre-installed. In that case, your license cost, or your cost for your hour of an EC2 is going to include the EC2 cost, the Windows Server cost, and the SQL Server cost. All right? So you'll find when you're choosing an Amazon machine image to launch that our Linux images are a little bit less costly than our Windows Server images, and the Windows Server images are a little bit less costly than the ones that also have SQL Server on them. And there's the URL to get started. We also have the AWS Marketplace, where you can quickly browse through different versions of software that are available. For example, SharePoint Enterprise is offered in here by one of our partners. And so finally, I'm going to conclude with next steps. You can set up your AWS account and take advantage of the free tier. Now, the free tier is really neat. A lot of our services include what's called the free tier. For example, in EC2, the free tier is a T2.micro instance type. Now, that's 1 gigabyte of RAM and 1 virtual CPU. Obviously, that's not enough to run SQL Server. But it is enough to deploy IIS and write an ASP.NET application and get started that way. And you can do that for free. So to learn more, go to aws.amazon.com/windows. And one other thing I want to mention that's not on the slide here, I apologize that we didn't get that in, but it's an important URL I want to tell you about. It's quicklabs.com. Now that's Quicklabs spelled Q-W-I-K-L-A-B-S, quicklabs.com. If you go there, you will see that we have about 100 different hands-on labs that you can launch for AWS. About 30 of those are just focused on Windows topics. We have quick labs for PowerShell DSC, SQL Server, SharePoint, high-performance computing, Microsoft HPC, .NET. We have several for .NET and Visual Studio, Active Directory. So there's over 30 of them available just around Windows topics. And some of the quick labs are free. All right, so with that, I'm concluding now, and we can take any questions. I'd welcome anyone to have any questions. Just raise your hand or come up to the mic. If you shout it out, I will summarize your question and make a synopsis. Yes? Can you talk a little bit about how the Active Directory Oh, good question. Okay, so the question is, how does Active Directory service work? I apologize we didn't have a detailed slide in there about this. So the first option you have for running Active Directory in AWS is to build it yourself in EC2. You can install or launch an Amazon machine image with Windows Server and then add the Active Directory role, and then other Windows servers that you launch in your virtual private cloud, you domain join them to your Active Directory running in the cloud. So that's one option. Another option is to use our Direct Connect service between your AWS cloud and your on-premise environment where you probably have an existing domain. So now what I'm saying here in this option is, when I build new things in AWS, new servers, new EC2 instances, I want them to domain join back to my on-premise domain. And the way that I'm going to do that with reliability and encryption and low latency is by having the Direct Connect service between my on-premise environment and AWS. Okay, now we're going to get into a couple of other options. We provide 3 flavors of a managed service for Active Directory in the cloud. We call this the AWS Directory Service, and it has an option called, which is a proxy. Basically what happens with the AD Connect service is you are going to, whenever you have a request to authorize someone in the cloud, like let's say I'm logging into your SharePoint instance in the cloud, and you need to verify my identity, that identity might be stored in the on-premise Active Directory. So what you can do is use our Directory Service Connect feature to proxy that request back to your on-premise domain. Now we get into another option, which is where you actually run our managed service, directory service in the cloud. So in this case, you're building a new domain. Now in this domain, it's actually amazingly easy to set up. It only takes about a minute in the wizard. You go into our directory service and you say, I want to create a new domain. You name it, and you create your domain administrator account password for that, and now you've got a domain. When you launch EC2 instances on the Windows, on the wizard, it asks you, what domain do you want to join this instance to? And you can specify the name of that domain service that or Active Directory service that you've already created. So there's several options, and you can do hybrid architectures where you have existing domain servers at multiple locations, branch offices, and you also want to put additional domain servers in the cloud for further fault tolerance or to be closer proximity to your remote users. Yes?
What sort of pricing model does that last Active Directory managed service use?
Well, okay, so I'm not going to quote the pricing right here. I think I don't have it all memorized anyway, but the thing I'll do is suggest that you go online and look at our pricing page for any of our services that you may have pricing questions. One thing to keep in mind is that all of our services are priced per region. So if you are looking at our service, you might find that the prices in our Asia regions are a little bit higher than our prices in the US regions. This has to do with the fact that the infrastructure and the bandwidth is more costly in other areas of the world than in some. Yes?
You said QuickLabs earlier. That's QWI.
Yeah, quicklabs.com is spelled QWIKLABS. Quicklabs.com. I really encourage all of you to check that out. We've got 30 Windows Quick Labs there. There's another feature I mentioned was Quick Starts. So for that, go to aws.amazon.com/windows, and I'll give you a little hint here. Look at the resources. When you go to aws.amazon.com/resources or /windows, click on the resources link, and you will find a whole bunch of information available for developers and about DevOps and about our quick starts, about our white papers. You know, we have something like, I think it's now 30 or 50 white papers available that are related to Windows topics. So we got white papers on SharePoint and Active Directory and .NET, etc. Yes?
Are instances ever moved? So if the physical hardware crashes, do you lose the instances, or are they shifted, or are they ever shifted?
Okay, the question is about, are instances ever moved? And if they crash, what happens? Are they moved? I'm going to answer that in 2 parts. when you launch an EC2 instance, if you don't use our placement groups feature, all you do is you're picking an availability zone. So you say, I want to launch this instance in the EC2 East AZ that is called, on my account, it might be called A or B, C, D, or E. So you pick out the letter of the availability zone you want. That's all you know about where it is. It could be in we have a number of facilities there. Now, the question is, what if it crashes? Well, if it crashes, that instance is terminated, and you would have to launch another one to put your workload on that. Now, one of the reasons that you can do that is that we provide the Elastic Block Store service so that your data, most of your data would be on the Elastic Block Store, not on the ephemeral storage on the instance. Each instance type, or most of the instance types, have ephemeral storage, which is a very low latency drive because it's attached, the physical hard drive, to the machine. But that's only for temporary data because you want to be able to withstand the loss of a machine. So you don't want to put your database on the ephemeral drive, but you might want to put your TempDB on the ephemeral drive. SQL Server TempDB is a good use case for that. So now let's say that I've got my EBS volume, which is actually like a SAN in the cloud. Okay, so we're giving you a slice of a SAN that is separated from your EC2 instance. They're very close and they're very low latency, but they are distinct. So now, when you terminate your EC2 instance, either because you decide to do it with auto-scaling rules, like for example, you could say, I don't need 10 SharePoint front-end servers on Friday night at 5 p.m. I'm going to close down 6 of those. I only need 4 maybe, 4 out of 10. So on Friday nights, you shut down some of your servers. So that's a schedule that you've said, I want to do this. Or an instance may crash for some other reason. When that happens, the data is still stored on the EBS volume. It's just no longer attached to that EC2 instance. Now, to get to your question, okay, so let's say I shut down a SharePoint server on a Friday night. Now it's Monday morning. I want to bring it back up. Is it located in the same exact place? Definitely not. It would be, you don't know where they're exactly located, neither do we in the racks. We don't, AWS employees are not allowed to know anything about what our customers are doing in our data centers. So we can't find the racks where your servers are. And what happens is our algorithms that are placing those instances are automatically choosing one near your other resources in your account and for best optimal use.
But they're not moved when they're running?
No, they're not moved while they're running. While an EC2 instance is running, it's actually continues running and cannot be moved. Okay, well, again, if there's a hardware failure, then when you relaunch an instance, when you launch a new instance after a hardware failure, you are launching a new instance. You do not launch the same one. Now, this, for those who might not know, this gets into the philosophy of the old way we used to do this like 10 or 20 years ago. We had a bunch of servers in our environment, and we named them like pets or rivers. I remember naming a bunch of my servers as cities like Miami and Chicago. But we don't do that anymore, right? Because in the DevOps world, you have to be thinking about really disposable computing. You literally can launch a server and shut it down minutes later. If something goes wrong with the configuration of a server, like this is a good use case for really understanding CloudFormation. When the CloudFormation template is running, if this whole stack is not created, what do you want to happen to the half a stack that was created? You don't want to pay for that for 1 second more than you have to, right? A half a stack is useless to you. So what CloudFormation does is it automatically rolls back everything. If it does not get 100% perfect deployment, CloudFormation says shut down the whole thing. So that's an example of we created a server and just literally seconds later we shut it down. It didn't work for some reason. Let's say there's a bug in the CloudFormation template where you've tried to domain join to a domain name that doesn't exist. Okay, so you launch the instance, but the domain doesn't exist. You can't join to it. Well, that's a failure, so just shut everything down. And now you have to go in and look at the logs and figure out, why did that stop? Well, why didn't it work? And you can preserve the logs, and you can tell it not to roll back if you want to. But the default option is to automatically roll back the whole stack. So back to the story about the pets, or the rivers, or the cities. The point is, don't think of your servers as having names. They're all temporary. And in the disposable cloud computing world, it's really actually brilliant once you start to get the hang of this, how you can say, that's pretty powerful. I can launch a SharePoint farm to do a demo. In an hour, I can do the demo, and then I can kill it. I don't need it any longer. I just click one button in CloudFormation and it shuts down everything, including the storage resources that I had attached and the databases that I had loaded with the temporary data for the demo. All of that can be up and down in super short order. And that's also powerful for scaling web applications when your startup buys a Super Bowl ad. Yes?
Or say you're a production farm, you've got some servers and you're running them throughout the week, you want to go offline for the weekends to save energy or whatever.
Right.
Cost, of course. What automated services or scripting, what tool are you using to shut those down at scheduled time and also bring them back online and say what's running?
Okay, so the question is about how do you, what service are you using to automatically scale up and down and bring something back online on a Monday morning? So we have a feature in Amazon Elastic Compute Cloud EC2 service called auto scaling. The auto scaling service allows you to set the time of day where you want servers to come up and down, or based on metrics that you define, like network traffic. So if your network traffic is beginning to spike up to 50 megabits per second, you could say, well, I'm going to need a couple more instances. Or if your CPU load is beginning to go over 60% for over a minute, you'd say, well, that's probably a time, it's been over a minute at 60%, maybe I better start scaling up a couple more instances. Now, a key point I want to bring up here for the Windows audience is that you have to remember that Windows Server takes a few minutes to boot the very first time. The first time you launch a new Amazon machine image with Windows Server, it's going to take about 3 to 4 minutes for you to be able to launch that and have the administrator password made available. What you want to think about doing to get really automated with DevOps and to give yourself, your organization, like a 10x edge over the competition is to fully embrace DevOps and think about continuous integration. Now, in this regard, you want to think about the golden machine, the golden image that you will make. So let's take SharePoint as a particular example. I cannot literally launch SharePoint in 3 minutes, right? Because you have to install SharePoint on top of Windows Server. And we don't provide you an Amazon machine image with SharePoint. You can get it from our marketplace, provided by one of our partners. But when you think about your custom applications that you want to put on, whether it's your HR or your CRM application and others, you're going to need to add that to the base Windows Server image that you might buy from AWS. So the question is, when do you do that? Do you do that when you launch? You install the application every time? Well, that's going to increase your launch window. Or do you do it beforehand and you save an Amazon machine image of your own? Now, that's the recommended way to do this, and we call that making your own golden image. So here's how this works. I launch a standard AWS image, a standard Amazon machine image, an AMI, that has Windows Server 2012 R2 on it. Then I install IIS. I say, because Windows doesn't put that on there by default, right? So let's say I want to put IIS on there. So I put that on there. And then I have some third-party tools that I want to put on there, like SSL library or an intrusion detection system or something like this. And I install the latest version of the .NET framework. Maybe it wasn't on there yet. So now I've got this image looking the way I want. And I also maybe make some registry changes the way that my application needs them. Okay? Now, everything is made to this Windows Server the way I like it, except it doesn't have my application code on it yet. But this is the time right here where it's kind of a bridge. Think of a spectrum between do you have a base image or do you go fully configured, including with your app? So the right answer is probably somewhere in between. But there are customers that are doing it at both ends of the spectrum. So if you go with the base image, you've got to put all this stuff on there every time you launch an instance. And with auto scaling, if you say you want to launch an instance at 9 a.m. on a Monday, that means you've got to wait until you get all this stuff on there and you fully bootstrap the instance before that instance is available for your users. On the other end of the spectrum, you not only bake all that stuff into the image, but you also deploy your application code. Now, the reason that's not really the best idea, perhaps, is in some environments, your developers might be changing your source code 20 or 100 times a day, right? So they're deploying literally with continuous integration. Every time they check in code and it passes unit tests, you may want to put that through an automated QA test and be available to go into production in the next cycle. But if you're changing your application 20 times a day, it's not going to help you to bake an image that has that code on it. So probably what you want to do is something in between where you've at least installed IIS and any other Windows Server roles that you want, and any third-party tools that you may like. Like, let's say you were putting OpenSSL library on there. That doesn't change that often, right? So you've got that on there, and you've got IIS, maybe your registry setups that you need. Then you're going to, every time you launch the instance, you'll put your new application code on there, as well as they're changing the application code, you're going to redeploy that each time. And that's where you can use EC2 run command. For example, you can run PowerShell commands to your whole fleet. So in that case, let's say that it's 9 a.m. on a Monday, I've automatically launched my own machine image, my personal golden image that I've made. I've launched it, and it bootstrapped all those baseline things. Now I've run an EC2 run command that automatically puts my latest application code from my development team on there. And then at 10:15 a.m., I get a message that the QA team has just blessed the latest version of the build of application code, and it's ready to go into production. So we can fire off an EC2 run command that pushes out the latest production code to those servers. And of course, you could also do this in what's called a blue-green deployment, where you keep the old version of your application running for, say, 90% of your customers, and you take a few customers that are coming in, or a certain pilot group, say, and you run them with the new application code for an hour or a day. You see how that's working. If there's no hiccups or explosions happening, then you can move more and more of them from the old environment to the new environment. And as you get 100% of your users going into your new deployed application, you shut down the previous environment. Yes, in the back first.
Yeah. Two questions, patching, and then you mentioned Windows 2012 R2. At some point in time, that will be end of life. Who has the responsibility for those upgrades?
The customers have the responsibility to patch the upgrade, to patch and upgrade. Now, once you launch an EC2 instance, we cannot see in it. We do not know what you're putting in there, and we do not touch the OS after you've launched the instance. But each month, as Microsoft updates Windows Server, we update our Amazon machine images. So if I went in there right this minute and launched an Amazon machine image with Windows Server, I might get a notification that says, there are updates available from Microsoft. Would you like to install them? That can happen if I'm in a short window of time between when Microsoft has come out with those and we have updated our AMI. So there's a lot to talk about patching. We really can't cover that in detail here. But yeah, next.
One final question about faults. When you guys need to take a server down for maintenance, what does that look like?
So it happens with a lot of advance notice. If it were to happen, we would notify customers that we needed to migrate them to a new instance. We're a very customer-centric company that's like burned into it's in our bloodstream, and we are very conscious of that. I don't have more details on that right now, but sorry. Yes.
Can you talk about virtualized SQL IOPS versus the standard model of bare metal and SSD and all that?
Whoa, okay, so the question is about the performance of virtual SQL, IOPS versus bare metal, et cetera. There's a lot to cover there. We do have some white papers that get into the details on our storage. For example, we have three kinds of elastic block store volumes: magnetic, SSD, and provisioned IOPS. The provisioned IOPS are SSDs, but with a guaranteed SLA. For SQL Server, for most workloads, you probably want to be able to guarantee have the provisioned IOPS guarantee with that for your users. There are cases where high performance is actually less expensive on regular SSDs than it is in PIOPS, but typically you want to look at PIOPS for high performance workloads like SQL Server. I won't try to pretend to stand here and quote any numbers on the performance levels, but we do have lots of white papers. Is there a particular question about how that works that you're interested in? Or? Okay, I'll make one comment about this. Remember that IOPS in the industry are, sometimes in the storage industry, in my opinion, I've read this online as well, they're almost meaningless because different vendors will say different things about them. One vendor might say, we do 10 million IOPS. That's I/O operations per second. Well, what kind of an IOP is he talking about? Maybe he's talking about a 1 kilobyte sequential read. Now, sequential is fast, and read is faster than write. And the next vendor might say, oh, we only do 10,000. Well, what's he talking about? Maybe he's talking about a megabyte random writes. Random is harder than sequential, and writing is harder than reading. So is one vendor faster than the other? You really can't tell. So you got to get the IOPS story to be the same. What we've actually found is that latency is more important to most end users than IOPS. But at any rate, we define IOPS for you as a 256 kilobyte read or write operation. So when you read on our web pages about the IOPS that we provide on SSDs and on our PIOPS volumes, PIOPS means provisioned IOPS, you will see that we're talking about a level of, a number of 256 kilobyte reads or writes. Now what does that mean? If you wrote 384 kilobytes, that's 2 IOs. If you wrote 10 kilobytes, that's still 1 IO, even though you didn't use the full 256. Okay, yes?
For those of us that already have Azure front, is there a VPN connectivity that's compatible with AWS and Azure?
The question is there a VPN capability that's compatible with Azure for like a hybrid environment? So I don't believe there is a simple yes answer to your question, but I will say that everything is software, so it's all flexible, right? We can do anything with software. So we can have REST APIs in Azure that are calling to services in AWS and vice versa. We can authenticate with Google IDs and Open IDs. So you can actually have hybrid architectures that are touching on your on-premise resources, the Google Cloud, the Azure Cloud, the AWS Cloud. You can build applications that do literally anything. Just because you may already have Office 365, that's no reason not to look at AWS and its capabilities. We have many customers that are using SharePoint Online, for example, in Azure, but also are using AWS. Okay, just a couple minutes left. Any other question? Yes? Okay. The question is, when you use AWS security groups, is there any performance difference between Linux and Windows, and are there any limitations on Windows that are more or less than Linux? And the answer to both of those is no. The security groups feature works in AWS regardless of whether it's a Windows or a Linux instance, and it's completely transparent to Windows and Linux. So you get the same number of security group rules, and the performance will be the same on all of them. The question is, if you have the maximum number of rules in a security group, which I guess I believe is 250, I don't recall off the top of my head, but I'll take your word on that being a limit. Is the performance, does it begin to degrade? And there are some of those cases where we've provided a soft limit because we know that the performance will be best if you keep it below that count. That may be one of these cases. I won't exactly pretend to explain how that works under the covers. But there are many limits in AWS that are called soft limits where you can just simply request that you want more. In general, though, the more security rules you have, the more that it's going to have to look at those rules to see if every packet applies to that rule before it allows the packet to pass through. So you can easily imagine that if you had thousands of rules, your network traffic would be a little less performant than if you only had a few rules. Security group rules are I don't think it would be that typical that you would need a whole bunch of them because you're specifying ports that you want to open. So for example, I want to open up port 80 from anywhere because I want customers from all around the world to be able to get to my website. So I need 80 and 443 from any IP address. Then I might want to say that I want port 3389 for me to remote in with remote desktop protocol, but I only need that from my corporate environment, so my IP address range. And then I probably, in many cases, I want no other rules whatsoever in that for my public subnet. Another thing you can do to reduce the number of rules in your security groups is to have rules that say this security group is the one that is allowed as the source of the rule to get into this other security group. So that's a very powerful feature. You don't have to put IP addresses in there. You can say that the source of this rule is a whole other security group, meaning any instances in this other security group are allowed to talk to this one. Okay, I want to thank you all very much for coming today. You're a great audience.